So my name is Robert Gay Schofield. I am the user interface architect for mobile applications at Wolfram, and I'm going to be talking about CDF deployment on mobile devices, and I'm going to be focusing a large portion of my talk specifically on what we're going to call CDF Kit, which is our SDK for iOS applications to display and interact with CDF content. That's my little boy. He likes his iPad. So first of all, let's take a quick look at what can be done with CDF on iOS today. So just a few examples. Basically, anything you can do in a notebook should work in the desktop Mathematica should work in CDF on iOS. We do not have 100% compatibility, but we're getting closer and closer every day. Things are looking pretty good these days. We have regular notebook content. We have dynamic stuff, graphics, typesetting. This stuff is all, there's no bitmaps going on here. Everything is being rendered in very high resolution on these devices. We have 2D and 3D graphics. 3D graphics are neat because you can interact with them. Just tap them with your finger and you can rotate. You can even toss them and they'll keep going and you can watch. We have controls that you can interact with. Checkbox, sliders. These are things that work very well for a touch interface. There are some changes that we've had to do, in particular for manipulate to deal with the touch interface. So normally when you have a manipulate, you have controls right on top of it that you interact with. If you try that on a touch screen, your hand is going to be covering the content. So we have taken some liberties with various options to manipulate to change the appearance. So by default, we put stuff down at the bottom. That way, you're not covering it with your hand when you're trying to interact with it. And you can do regular manipulate things just as you would expect. Even works with 3D graphics. In the 3D graphics, you can still move them around while you're manipulating. So the state of mobile CDF deployment. We've been working on this for a few years, and you've possibly even seen demos of it at past conferences. So where we are today, in the past year, we've made big improvements in performance. We've made big improvements in compatibility. And we have put a lot of time into putting together this SDK so that other internal projects can make use of this. And also, we can partner with other companies and individuals to allow them to embed this technology into their own iOS apps so they can author content in Mathematica and deploy it on mobile devices. There are just a very small number of new features we've added for touchscreen devices. The first is a new function or current value called touch position, which is kind of similar to the mouse position function in Mathematica, except that it returns multiple values because you can touch the screen in multiple places. So if I touch once, it's going to give me one set of values. If I put another finger down, it's going to give me more and more. And it can also have 0 values, unlike a mouse position. So it's very similar to mouse position, but slightly different semantics that you have to be prepared for to handle the cases with multiple values. We have a new function called gesture handler, which is similar to event handler, but allows you to hook into gestures like drag and pinch. And there are some quirks to this. Normally, when you touch the screen, it's for scrolling. And when you pinch, it's for zooming. So in this sort of scrolling situation, some of the gestures don't work right. But if you have a content which is statically sized, then it works fine. And I'll show some examples later with static content rather than scrolling stuff like this. But if you kind of very carefully, oops, it's the first time that's happened. you can do some things. So I'm just responding to a drag gesture, and there's a small drawing bug in this example. Sorry about that. That will be fixed. And as I'm dragging across, the size of the disk is changing in response to my drag. We have an option called touchscreen control placement. As I mentioned earlier, by default, we put the controls at the bottom. If you really want to override that and say, put the controls on one side or the other, you can use this touchscreen control placement option. And for this example, I'm just going to put a vertical slider over on the right-hand side of the screen for this manipulate. So if your controls are very tall but not very wide, maybe putting on the side would be a better option for you. And then the final option is called touchscreen auto zoom. And what this means is that these manipulates are normally not active. You have to tap on them to activate them to get the controls to pop up. And when you set the default value, touchscreen auto zoom false, it appears just as you would expect. If you set touchscreen auto zoom to true, you'll get larger content that zooms in to the thing that you're interacting with when you're interacting with it. So CDF Kit. This is our software development kit for iOS. Clients can embed this into their iOS applications. You can display and interact with CDF content. And you can perform evaluations, kernel evaluations, using Wolfram language expressions. There's a few different types of applications you could build. You can have an app like the one I'm using right now, which kind of revolves around the CDF content. The CDF content is full screen. It scrolls. It zooms. This is John mentioned in his talk a potential CDF player application that we're building, and that's what I'm using right now. This is just a normal notebook file that I authored in Mathematica. I loaded it onto this device, and I'm just viewing it. There are other classes of applications, demonstrations apps like the one that Stephen demoed in his talk. And ebook applications. So let's just take a look at an example demonstration app. So this is a custom home screen, but this is nothing more than a CDF file, and we have some other demonstrations we can look at. So we can go to one of these. We see the title, the description, and we get some content. I can tap on that to activate it. Excuse me. And unfortunately, it's not doing what I want. Sorry about that. And we have some navigation functionality up at the top here. We can skip to the end, look at other demonstrations. So that is an example of a demonstrations type app. And ebook type apps. There's an example of a book type document that could fit into a larger application where we have mixtures of text, graphics, typesetting, interactive figures. Everything is scrollable and zoomable. So that's one type of application. Another type are cases where you have a lot of other stuff you want to go on in your application. Excuse me. Cases like the Wolfram calculator, for example, where there is an entire iOS custom user interface built for this application, and then it embeds little bits of CDF inside of it. So we can look at the calculator. And so what we're looking at here, there's no CDF being displayed on the screen right now. But we can do a quick computation, and you see there is custom UI up at the top, middle and bottom, and there's a little white strip with the number 5 that is CDF-based content. So we can do something more complicated. So let's make a 3D graphic. So here again, we have CDF content. We can interact with this the same way as we can in other applications. And now it's important to note that these two outputs here, the 5 and then the 3D graphic, the calculator isn't doing anything different in these two cases. It has a CDF view, and it's just telling it what to display in that view. And then CDF-Kit takes care of everything else. It takes care of all of the OpenGL commands for the 3D drawing, and it takes care of the interaction with the user in response to the touch. And pinch and zoom, and you can 2-finger drag to pan, and you can even rotate it if you want. So we'll just do one more quick one. To show some of the typesetting. So here we have a slightly larger output that's all typeset. And again, the calculator's not doing anything special in this case. It just says, here's this output I have, display it in this rectangle on the screen. So let's look at a slightly different example. This is one of the examples that is included with the SDK just to show you how to use it. And this first one takes a little bit of time. Sorry about that. This is a custom user interface over here. We have a list of salt chemical compounds and a 3D graphic molecule plot from Mathematica that it displays for each one of these things. So we can cycle through these, and we have good performance for these things. We can interact with the 3D graphic. We can pinch to zoom and rotate and pan. We can toss it and watch it go. And this application doesn't have any 3D drawing code. It just has a CDF view, and it sticks some, a graphics 3D expression into that CDF view. And the CDF-Kit knows how to draw it, knows how to interact with the user. There is a shockingly small amount of code in this application beyond the template that Apple provides with Xcode. It's a total of maybe 20 lines of code to build this application. So I'm going to take just a moment to dive deep into some iOS programming bits and show you exactly how easy it is to integrate iOS-Kit into an application. So first of all, we have a CDF session, which is your connection with CDF-Kit. You create one of these and only one of them. When you do this, it's going to start the kernel on a background thread, which takes a small amount of time. So if you're planning to use it right away, do this as your application is starting up. And this is one line of code right here, CDF session, alloc init. And then you keep that around and use it later. Next is CDF document and CDF view controller, and these kind of go together. CDF document is basically a notebook file or a CDF file. You can create it from a file on disk. If you have pre-generated content, you can create it from a string in memory that gets parsed, or you can just create one that's completely empty. So here's the important bits here. You're going to take the session that you already created and create a document. And then you're going to use that document and create a view controller. And that view controller is going to have a view associated with it. That view you can do whatever you want with. So the calculator takes that view, it embeds it in its view hierarchy. That molecules app that I showed you takes that view and puts it over on the right-hand side. Then you can perform evaluations, and you can change the contents of the CDF view. So we have a class called CDF-Expr, which is used to represent Wolfram language expressions in Objective-C. And these can be things that are parsed from a string. You can construct them manually using low-level functions, or you can retrieve them from kernel evaluations. There is a CDF evaluator object, which you can use to perform evaluations. The molecules app example doesn't perform any evaluations, so it doesn't use this. But the calculator does use this. And just to get an idea what that looks like, we have an evaluator. It has a method evaluate-expr, which we give it an expression we want to evaluate. A flag to indicating whether we want it to be preemptive or queued. So preemptive is kind of the equivalent of a dynamic evaluation in Mathematica, and queued would be the equivalent of a shift-enter evaluation in Mathematica. So if you have some long-running queued evaluation, you can interrupt it with a dynamic evaluation that will return quicker. And since this all happens asynchronously in a background thread, you specify a block, a function, a callback function, a closure that gets called when the evaluation completes at some point in the future. And so in this case, what it's doing when the function completes, it's going to set the formatting width. And that's necessary because we want to have the content, we want to have line breaking in the content. We don't want it to just be really wide if it's a big output. We want it to be wrapped to the width of the screen. So we're going to set the format width, and then we're going to set the expression to the output of the evaluation. And that's all that has to be done. So that's all the code. In addition to the code, there are a number of frameworks and libraries that your app will need to link against. These are all pretty standard things. If you're used to doing iOS development, this will look familiar to you. And then just a couple more steps. There's a bunch of system files that go along with Mathematica, text resources, kernel, MX files, these sorts of things. These need to be copied into your application. And you can use a shell script, build phase, and Xcode to do that. There are fonts that need to be activated, so you have to make a small change to the info plist to activate the fonts. And then there are a couple of other miscellaneous steps which are hopefully temporary. But at the moment, you need to add a key to your info plist to tell it the class name of your application delegate. And then you need to call a function CDF main in place of the normal UI main function call. So that's it. A few changes to your project, about 20 lines of code, and you can build something like that molecules example. And just to dive a little bit deeper into that, the data that I used for that application comes from these two Mathematica commands. I basically used the built-in chemical data. I got a list of all of the salts that had a molecule plot associated with them. And then from there, I took the name of each of those, the standard name, and then the graphic, and I just dumped that into a data file. That data file was included with the application, and when the application starts up, it uses these 2 lines of code at the bottom to load the data file and create an expression from it. And that was it. So potential issues that you're going to encounter. Like I said, most things just work. There are some things that do not work, mostly just because we haven't had the chance to get to them yet. Obviously, we want to have full compatibility, but that's not where we are at the moment. So things like event handler mostly doesn't work. If you just want a mouse-clicked event handler, that does work with taps on the screen. Tab view is not implemented texture. Locator works inside of manipulate, but not outside of manipulate. Input field is missing. There is support for 3D transparency, but it is not as full and general as it is in the desktop Mathematica. So if you're doing stuff with transparent 3D graphics, you're going to want to take a look at them to make sure that they still work right. 3D arrows, there are some limitations, and some limitations with 2D arrows, and some kernel functionality is not there yet, things like networking, Wolfram Alpha, JLink, database link. And then there are performance considerations. The limited amount of RAM on these devices can cause problems if you are doing complicated evaluations. If you're not doing complicated things, it's not that bad. As you can see, I have run 4 different applications that use CDF-Kit during this talk. So that's 4 different copies of Mathematica that are potentially running at the same time. And then, in addition to the RAM, these devices have much slower CPUs than desktops and laptops that you're used to working with. So if you have a Manipulate, for example, that performs very well on a desktop machine, it will probably work OK on these devices. If you have a Manipulate that is a little bit laggy on a desktop, it's not going to be a good experience on these devices. So take some time to optimize your Manipulates. Make sure they perform really well on a desktop before strongly considering deploying them this route. And then one other limitation, the kernel session cannot be restarted at the moment. And that's something we're working on, but we don't know when that's going to be fully implemented. So once the app starts up, you have a kernel session, and you need to be prepared to live with that same kernel session for the lifetime of the app until it gets stopped. So that is what I had to show here. And I'm just going to do real quick one more thing and show that this is not all completely limited to iPads. It works largely on phones as well. So here is the molecules example. And there's a small bug that I need to fix, but here we go. We have the same list. We have the same molecules. I can interact with them the same way. And then I also have a CDF player build here, which has some UI issues because we haven't really spent much time working on the smaller form factor yet. But things work. We have the notebook here. It's unfortunately line wrapping to a very small width here, but we still have dynamic. We still have all of the graphics, manipulate sorts of things. And I can even look at the contents of this talk, and you can see touch position is working. I can.
Can you switch?
I thought that these notifications were supposed to be disabled when the projector was plugged in. So that is that. Are there any questions?